So the homework last night was on page 28. And I think we did at least one of them. Yeah, we did one together. So starting off, rock layer A is younger than. So you just had to go to rock layer A and decide who is younger than it.
B.
Okay, and I'm going to ask random people. Destiny, why is B younger than A? So this is not part of the homework, just kind of review. Why is B, how do we know B is younger than A? I'm sorry, B is older than A. So how did you know the answer to number one, that B was older than A? How do you know B came first? So you gotta be careful with how you word this. By saying B came first is another way of saying B is older, but how can you tell by looking at it? Where is B? If this was your laundry, how would you know B was, yeah, B's older because, and this is not part of it, but I want to make sure you're able to do this. We know B because it is lower, or it's below, or it's at the bottom, any way you want to word that. The regents will most likely follow up every one of these questions with a, how did you know? All right, going on, layer Z. I feel like this is a trick question. I want to see what you guys said. Layer Z, everybody tell me what they said is the same as what layer?
H.
H?
E.
E. Is it H?
Oh.
Or is it E?
E.
Not both.
Dang.
Okay, it definitely can't be both. So keep in mind, if we're looking at layer H and layer E, is there a difference between those two? Okay, that's actually one thing, is H is curved, E is not. But what's another huge difference? Yes, they're the same kind of rock, but what do we know about E versus H? Age, yeah. E is much younger than H because E is much higher. So they can't be the same layer, and only one of them can be the same as Z. Take a second, reevaluate this one. Which is the same as Z? Is it H or is it E? I could not have said it better myself. The answer is E. And here's why. If we look at Z, what's below it? That looks like conglomerate, the one with the big blobs. And what's above it is the bricks, limestone. If we looked at H, below H was limestone, above H was the conglomerate. So it's reversed. We can't reverse them. So we double check E, below it's conglomerate, above it's limestone, just like it was supposed to be. Another thing, like Carter had mentioned, was Z bent? No, yeah. No, Z is not bent. Z is nice and straight. H has been folded. So you can't just fold part of a layer. So Z really matches up with E, and they totally did that to you on purpose. So they totally expected you to say, oh, Z is the same as H because they're dashes and they're near each other, but they mess with your head. Z is the same as E.
I got that right.
This next question, in which rock layers are fossils least likely to be found? This is a throwback to chapter 3.
G.
No.
I don't know.
Anybody know?
What are you asking?
Why C?
Oh, yeah.
Because it's what? Can't have fossils in magma. So C is an igneous rock. You can't have fossils in igneous rock. There's one more then. You also can't have it in metamorphic rock. None of these are metamorphic though.
I.
No, I is the unconformity.
No, the under top, like that. Nope, over.
This?
Yeah.
That is C.
Oh.
This I is pointing to the fault. The other one that's igneous, if we look at the key, this guy right there is igneous rock. B is also an igneous rock. So again, this is one I would expect the regents to say, well, how'd you know? So again, how do we know that there's no fossils in B and C? Okay, no fossils in igneous rock. Next one, is C going to be an intrusion or an extrusion? Before you answer this again, I want to know the difference between an intrusion and an extrusion. Okay, that's the basic. One inside, one outside. But there's something else. Contact metamorphism. So remember, the contact metamorphism, the little hairy marks, happen when a rock is there and gets touched by the hot lava. If there is no contact metamorphism on it, then that means there was no rock there to be touched by the hot lava. So if we examine C, what do you think now? Extrusion, and again, why?
Because there's no contact metamorphism.
Okay. Extrusion, and I loved how you corrected your explanation. A lot of times people want to just say, so when I would say why, you would answer with contact metamorphism. I know what you mean, but you have to use more words. You have to say no contact metamorphism. So again, they're going to ask you why. And the reason why we know this is an extrusion is because there is no contact metamorphism, but not just on top. So again, I'm not huge on complete sentences, but it has to be that complete thought. Everything you were thinking when you made that decision. And okay, because this is an extrusion, again, throw back to chapter 3, because it's an extrusion, will it have big or small crystals? Okay, if you guys don't remember. So it's an extrusion. Do you remember the two different types of igneous rocks? Intrusive and extrusive. Remember, extrusive, they're volcanic, they form on the surface. If we go over, they either have no or little crystals. While intrusions, the one that form inside, they have either coarse or very coarse, so big crystals. So will this guy, who we already established is an extrusion, have big or little crystals? I heard the answer. Again, they're going to be small. They again might ask why. Why will they be small crystals? Cooled fast on surface. They will ask you a lot of those why questions. So they're gonna, yes, expect you to know the answer and be able to explain it. This is the big chapter where they expect you to do this. All right, these next two are pretty easy. What is G? Polka dots. Sandstone. What is A, which is the bricks? Limestone. We did the next one together yesterday when E, which was shale, touched hot lava. It turned into slate. We got that from right here. We looked down at the comment section. Low-grade metamorphism of shale is slate. So now we got to do the same thing for letter A. So A was limestone. Which metamorphic rocks come from limestone? Yep, metamorphism of limestone or dolostone. Marble. And finally, which metamorphic rock would be found in layer D at the site of contact metamorphism? So here's D. Which sedimentary rock would you say D is? Conglomerate. Now this one might be a little tricky because it doesn't say word for word, but I bet if you use your common sense, you can figure it out. Yeah, meta-conglomerate is when conglomerate gets metamorphosed. So meta-conglomerate. Technically, I don't think the Regents will ask you that one because it wasn't word for word on the reference table, but I think you can figure it out. You guys good with those types of questions?
Yeah.
How'd you do? Good?
Yeah.
Decent? Okay, now just remember, you're gonna have to be able to add the Y's. All right, so yesterday we were working on adding in notes that I had forgotten. Is this truly all we got to? We did the definition of correlation, outcrop, and then index fossil. Did we write the 3 things that make a good index fossil?
Yeah.
Okay, so let me add that. 3 things to make. So we're on page 20, which is just a blank sheet of paper. So there were 3 of those. You already had those from yesterday. We are, and then did I show you? I think we did, because Sarah said, how do you even begin to clean up the asphalt?
Yeah.
Is that, okay, so we do need to add that one, and I'm just gonna grab the PowerPoint. Maybe. Okay. So we didn't write it, but we talked about it. Lost it. There we go. So we showed pictures of it. We talked about those are the ashes coming out of the volcano. They'll get blown away, blown all around a huge area because they're really light and the wind can carry them. And then when they start to fall, they're going to cover the entire area in a layer of ashes. Just like any sediment, these ashes can get buried, compacted, and cemented together and will be a thin layer that covers a large area. So just like index fossils, volcanic ash falls are widespread geographically and they make a good time marker. So can you add that to your page 20 notes? So they work just like index fossils. We know when they happened. And they're going to be spread out over huge areas, so they work really good like index fossils. So I say they work really good like index fossils, but I'm not sure you guys actually realize how index fossils work. So I have a really good picture to show how index fossils work. What? Okay. Ready for this? I have a picture. Okay, I don't know where the picture went. There we go. Here's the picture. Do you guys know what this is? Yeah, it's built up snow. This was from the first snowstorm back like when you guys were in 2nd or 3rd grade. I don't know how old you were. The first time we got like 8 feet of snow all at once, or at least we did out closer to Buffalo. You guys, I don't think got much that time. It was in November. School's closed because none of your teachers could come to school.
November.
Yeah, that was the original Snowvember. So when it was over, we had snowbanks that were 6, 7, 8-ish feet tall. And how they took care of them, afterwards they found this ginormous snowblower. I swear this thing could have eaten your car, snowblower. So like we're talking about a huge snowblower. And they took that snowblower and just started, just like you would with a snowblower, taking it trips down the road. And I was driving my kids, I believe, to gymnastics, because where else do I go? And I saw this on the side of the road and I truly slammed on my brakes and took a picture. Husband and kids thought I was nuts. But I loved this picture because it relates to the layers of rock. It's hard for me to picture layers of rock because I don't see them every day. But I see piles of snow every day, or unfortunately too many days. And you guys do too. You've seen snowbanks that look similar to this. What you probably haven't seen too often is this was truly taller than my car. So this was a giant snowbank. Just like rock layers, this snowbank kind of tells us a story. And you guys are familiar with some of these stories. So first of all, why are some of the layers whiter than other layers? Why are they dirtier? Let's start there. Why are some of the layers dirty? Is that how snow
Because
gets
they
dirty?
were on the ground and then they were like ran over and stuff and then it was pushed up, so.
Yeah, there's a couple of reasons. So absolutely, when they sit there longer, they get dirtier looking. That's part of it, but what's happening here is, what do the plows put on the road?
So,
Salt and sand. They put a fine layer of sand and salt on the roads to keep people from slipping. That's the dirtiness that you're seeing. So the cars get dirty, the roads are dirty, the snow is dirty. So when the plows are out doing their thing, the snow that they're pushing tends to be dirty snow. Makes sense, dirty snow being pushed around. Well, then how the heck did this really huge layer of white snow? Keep in mind, this is like 8 feet tall. This is probably a 2-foot section of snow.
it snowed again and it just was on top of that layer.
So it did snow again. And what actually happened, and just like this last snowstorm, the plows couldn't keep up. The plows didn't even come out because they couldn't drive. It was snowing like feet per hour. It was insane. So this is a time when it snowed really long, really hard, really fast. Then you could see the plows got back out, but then we got hit with a second round. So it wasn't as bad as the first round, but you can see another whitish layer. And then they were able to stay on top of it. So the snow tells a story. Just like the kinds of rocks in the rock layers tell a story. Remember we were doing yesterday, what if they found conglomerate in the rock as one of the rock layers? What do we know about what was going on at that time in history? If there was conglomerate with those big sediments, what kind of environment was there? We did this yesterday. Conglomerates form where? Holy cow, do you not remember? Flip back to our pages. Maybe if I say it like this, what about breccia with big sediment? What kind of thing was happening at that time? Where were they being deposited? Shit, oh, you do remember. Holy cow, that was painful. So knowing that there was conglomerate there would mean it was shallow water at the time. But then if clay was getting deposited for shale, what kind of environment was it? Deep water. So the rock layers tell us a history of the place. The snow is telling a history of the place. In addition, where's the oldest snow in this pile? At the bottom, and where's the youngest snow? On the top, and in the middle, you know it goes from older to younger as you go to the top. Hey, ain't nobody, well, they do. They at least know it gets older or younger as you get closer to the top, older as you get closer to the bottom. But the next thing that you may have learned in lab, or you should have taken away from lab, is when we find certain fossils, we know exactly how old something is. Here's again how I'm going to relate it to the snow. So now instead of this being one like day's worth of snow or 3 days worth of snow, we're going to pretend this is the whole season's worth of snow. So unlike this year where it literally snows and then melts and snows and it melts, let's pretend it stayed the whole winter. We're pretending. And I find some interesting little objects in those layers of snow. Yeah, if you can't see, this says Happy New Year. I find a Happy New Year's hat here. And if you can't tell what these are, they're Valentine's Day bears. So again, we're pretending, but work with me. Hey, what do you know about these? Why do you think I picked these particular objects? Well, they are both in the winter.
They're at totally different times.
They are. Like, could you go to the store today and find a Happy New Year hat?
Maybe in the clearance section.
Yeah, I bet even by now they're out. So you cannot really go to a Happy New Year hat. When are they around?
New Year's.
Around New Year's. Maybe a couple weeks before, maybe a couple weeks after, but they're gone after a short time. Get it? Short time period?
Yep.
Just like a index fossil. They're only around for a short time.
Yeah,
Are these easy to recognize? Like,
yes.
they are, yeah, they say Happy New Year on them. Not to be confused with Happy Birthday. They are distinct. They say Happy New Year. They're easy to recognize. Are they widespread geographically? Can you find Happy New Year hats pretty much at any store you go to in all of the United States?
Yeah.
Yes. Same with the Valentines. They're typically only around for a short period of time, around Valentine's. Yes, a little before, a little after.
And you can get chocolate.
Yes, but typically the hearts that say Happy Valentine's are only around during Valentine's. And yes, there are flaws in my example, but work with me. So again, Valentine's only around during Valentine's Day. They're easy to recognize. You guys, they do say Happy Valentine's on that bear's heart, belly, but they're hearts, they're pink. You know that goes with Valentine's Day. They're only around during Valentine's Day. They're easy to recognize and they're widespread. You can again go to any store pretty much in the United States and find one. Notice I didn't put up like a flag that said Homecoming Pioneer on it, because that's only for us.
It's not widespread.
Not widespread. A Happy Homecoming Pioneer would be useless because you're only gonna find them here. You can't go to Wisconsin and find a Happy Homecoming Pioneer flag.
Happy homecoming.
Okay, whatever, you know what I mean.
Pioneer.
Yeah, you know what I mean. So now, instead of just saying these bottom layers are older than the top layers, can we give a general gist or a general idea of how old they are? So for example, here's the Happy New Year hat. How old is the snow that's in with that Happy New Year's hat? When's it from? January 1st-ish. Yeah, so if this is, yeah, so maybe a little before, a little after, because they're around for a little bit of time. But for the most part, that white layer with the Happy New Year's hat is January 1st. How old is the snow that lines up with this Valentine?
February.
Okay,
February 10th.
so this general area is around February 14th. So now can we be more specific? How old could this snow be above February 14th?
March.
Could be March, could be March 15th, or it could be April. No, let's try again.
Could be February 15th.
We're not in March though.
I know, we're pretending, remember, they're pretending here. You don't do that much, huh?
No.
Okay, so the snow above February 14th is any time after February 14th. Could be February 15th, could be March 1st, could be April 10th. Who knows, as long as it's after February 14th. How about the snow down here below the Happy New Year's hat?
That's like December.
Okay, anytime before January 1st. Could be December, could be November, could be October. We don't know, we just know it's before January 1st. And in case you haven't figured it out yet, what do you think the age of this snow will be in the middle?
Anytime before January or after January 1st and before February.
Yep, so newer than January 1st, but older than February 14th.
Say anywhere between.
So at least it gives you an idea. Doesn't give you the exact date, but at least you can kind of get an idea of its age. So I kind of like the snow example. Hopefully that helped you guys. It's gonna really help with your homework.
Are you doing that one?
We have 2 more vocab words to add into. Now, I don't know, wait, before you write this one. An unconformity. Do you guys remember taking notes on an unconformity?
Yes.
If you can find your notes on unconformity, I am not gonna make you write this again.
Oh, right here, it's at the
Sarah, found it. Tell them what page, Sarah.
bottom of page 15.
Bottom of page 15.
Found it.
And it said, we wrote that it's a buried erosional surface. It's a gap in geological record, which is pretty much what I have here. It's a buried erosional surface. We did in our picture, hopefully, did you have a picture that included a wavy line on page 15? Perfect. It's a gap in the geological record, which just means it's a missing part of the rock sequence. I don't think we included this, but I think it's implied by saying it's a buried erosional surface.
Yeah.
So it's caused by extreme erosion. So I'm not gonna make you rewrite that on page 20 unless you don't have it on page 19 or on page 15. Did everybody have it on 15? Okay, so an unconformity, wavy line caused by erosion, missing part of history. Okay, two more words then, two more. So don't do this rock correlation part. That's just the title of the whole page right here. Folds, faults, and tilting. We have said this a bunch. I'm not sure we've ever written it. Folds, faults, and tilting, the movements are younger than the rocks they move. So the fault happens after the rocks. The fold happens after the rock. And can you do your best to show those 4 pictures there? How would I draw them? Let me see. Take undisturbed. I just have flat layers. Label it undisturbed. For the tilted, I would just take my layers and have them diagonal to each other. Folded.
Hey, just what's that last one?
Bugging.
Ew, please don't say that.
Tell me what to do there.
Yes, yeah.
So with the faulted there, the one that's bugging. If you notice, and maybe this was not quite clear that those are polka dots, not dashes. They're the layers, but I put that diagonal down the middle representing the break. And then you can see that the layers are just offset from each other a little bit. So any movement is always younger than the rocks it moves.
We got that as well.
A couple of people are still drawing, but thank you. And the last word, I know we've talked about it, and I've never seen them ask a question about it. The word is overturn.
Oh.
We did talk about this already. What I always see in the questions is it says, these rock layers have not been overturned. And I don't want you to get, like, when you see have not been overturned, I don't want you to get there and be like, what? Who cares? I don't know.
When the call is overturned.
Well, the layers being overturned or not being overturned. What are we talking about with, if you were to overturn some layers, what would you do? Flip them. And what's the problem with flipping rock layers? It messes up the ages. So instead of the oldest being on the bottom, the youngest would be on the bottom. So you guys know what it means. I just don't want you to get overwhelmed when you see not overturned. If they say they have not been overturned, what's that mean? They didn't flip. So you know the oldest is on the bottom, youngest on top. So I do just want you to put in the definition of overturned. You could probably just say flipped.
I know what I mean when I say.
Okay, I agree that most people can probably figure out what overturned means. When you're done writing this, we are done with the notes. I want to get you started on your homework. So flip over to page 29. Yeah.
Waiting.
Huh? No, I'm gonna tell you to skip 45.
Get 45?
Skip number 45. So you may notice that your homework is the last page of the packet,
There.
which you would think means we're done with the chapter.
No.
But if you forgot, we skipped like the first 5 pages of the packet. Or technically we did pages 1, 2, 3, and 4, but then we skipped like 6 through like 10 or something like that. So what we skipped is question number 45. So we haven't talked about question 45 yet. We're gonna do that as soon as we come back from break. But other than that one concept, we're pretty much done with the chapter. So after break, expect a test around Thursday or Friday.
Don't come back.
Okay, not Monday, Tuesday, or Wednesday, definitely thinking Thursday or Friday.
Thinking Friday.
And in case anybody cares, we are technically learning tomorrow, but I promise you, you will enjoy this learning more than any other learning we've done this year. No candy. I'm not telling you what we're doing.
Can we play games?
Nope, that I know we're not doing. So-
Lights.
I do want to help you with your homework.
No,
So
thank you.
first of all, stay with me if you want the help. If you don't, zip it so other people can get it. So not that one, because that has all the answers on it. So again, question 45, you can just go right ahead and cross it all the way out. We're not gonna bother doing that question ever. We will learn how to do it, but we're not gonna come back to this one random question. So I do wanna help you on question 14 or 41, which is similar to a lot of the following questions after this. So in the geological cross-section below shows an unconformity in New York State bedrock layers that has not been overturned. So again, just like we we're just talking about, they tell you they have not been overturned. So by knowing that, we know the oldest is on bottom, youngest is on top. Index fossils throughout some of the rock layers are shown. So we've got 4 that are shown that are in this set of rock layers. Now they want to know which one of these 4 may have been present in the rock layer that's missing due to the unconformity. To see the unconformity, they did label it here. So even though they labeled it, would you have been able to recognize this as an unconformity? Why? What about this picture shows it's an unconformity? The wavy line. So just the fact that the top is wavy means that's an unconformity. Basically, they're asking which one of these guys belongs in the layer that has been washed away, that's missing. How do you think we're gonna go about doing that? Definitely pages 8 and 9 of your reference table. Pages 8 and 9, these index fossils, so these pictures, you should be recognizing that they look like the pictures, like there's that dinosaur. This dinosaur is letter L on the bottom of your reference table. This dinosaur is acting like that Valentine's Day bear in the snowbank. What's this thing that looks like a paintbrush if you ask me? What letter is that? Not I, it's H. So I looks more like a feather duster. It's like got a V. H has that, the not V shaped one. So this guy is H. Do we know anything about these letters now? I and H, or L and H?
Yes.
Yes. We can see, now one thing that was not made clear, or that somebody had a question about. Here's L. Guys, shut up in the back. You're being incredibly rude. Here's L. L was only around for this circle, not the whole line. So L is a type of dinosaur, but this particular dinosaur showed up at the bottom of the circle and went extinct by the top of the circle. So that this one little dinosaur was only around for that circle. Same with H. It was only around for the space that circle takes up. So we're looking for something that came in between. Because we're looking for something in between, just like if this was the Valentine's Day heart and this was the Happy New Year's hat, this happens sometime in between that. Another thing I want to point out, these letters do not go in order from oldest to youngest. That's really important to notice. The only thing that you can tell how old they are is by where they show up here. So we got to figure out which one of these goes in between. This bird, what letter is this bird?
S.
Is it? Yep, S. This bird is letter S. Check your reference table. Does S show up in between those? Where the heck is S? S is way at the top.
No.
Is it between the two? No freaking way. How about this thing next to it, to me, that looks like an orange slice? T. Is T in between? Nope. T is down near the bottom. That fish looking thing, what letter is that?
R.
R. Is that in between?
Yeah.
There's R. Right there. So we don't need it to be here, just in this general area. We need it to be in the time frame that's between them. So absolutely, R does show up in the time between H and L. Does that make sense? And then just to double check, this thing that looks like a squiggle of poop to me, letter W. Yeah, I don't know exact, it's a gastropod, it's some sort of like snail type thing. So there's W, would that be in between H and L? Nope, it's down near the bottom too far. So that's how you use true index fossils to help you figure out how old something is. So you guys do only have about 4 minutes, but if you skip question 45, you only have 1, 2, 3, 4, 5, 6, 7, 8 more questions to do. So I do think you could probably get a good head start on finishing your homework on pages 29 and 30. And let me remind you guys that when you're absent, you're still required for any work you miss, or still need to turn in any work you miss. If you don't show me your work, I put in a 0 in the grade book. So if you're not going to be here tomorrow, make sure you still show me the homework when you come back.